the highest hurricane season ever recorded.
Mm-hmm. So is Michigan blowing up with COVID right now too? Or not so bad?
I know that the governor just closed like movie theaters, in-room dining, like restaurants, and a couple other things.
Okay.
But where I'm from, there's still only 200 cases.
Oh, really?
Yeah.
That's. COV.
That's right.
When you take, what is the course, the big group course, is that 300?
300.
Mhm.
I gotta take 291. That's the last class I gotta take.
That's, okay,
That's next semester, so
that's
that's pretty tough.
pretty, is that the stats class?
Yeah,
Okay.
it's the analytics too.
Okay,
So 191's pretty easy.
pretty easy.
Good to know. I have that next
Are you
semester.
business too?
Yeah.
Yeah, just.
Who's your
for fun.
professor? Who'd you pick?
I don't know. I can look though. I have him next semester.
Yeah.
They talk about 300, and the way they talk about it, it's not like the movie 300, you know, right?
I hear as long as you can get into 300, it's not as bad. I'll say it pretty sense.
Maybe they're getting weak in their old age.
Yeah.
They got the new building now, they can just. Are you guys in the new building?
So one of my classes is
Okay.
Stevens.
191.
Is it nice in there?
Oh,
It looks nice
class
on the
and then
outside.
it's like one wall is just one big window, and it's right, the lake's right there.
It's so nice.
Yeah.
Nice. The offices look, I'm not sure I'd wanna have like a big aquarium office.
Is it like to the left?
It's like behind the construction.
Okay.
It's beside, so the old building is the one that's being like redone.
Right now, yeah, that's.
Zach, I think we're taking Stevens.
Oh, okay.
Joaquin and I are gonna take it
Yeah,
together.
he's a little tough. I hear.
Dr. Warren, I heard this from one of my professors this morning. Apparently on Rate My Professor, you could like rate your professor's hotness. Like that used to be a thing. Is that true?
I don't know. I don't know.
I give you a 10, Dr.
Yeah,
Warren.
no, I don't think hotness and me go together. Yeah.
Yeah, I heard that this morning and I was like, why? And I was like, what is the point
I know,
of
I
that?
know, okay, well, that's.
Some people have
I've
different
heard that.
strategies for passing.
We had a teacher in my high school and he got fired for, but my best friend had him. Yeah. Yeah, but my best friend had him and she was like, every time I wore a low cut top, I didn't even have to study in class. She's like, I just got an A.
What?
And then so she was actually like, I hated that he got fired because then I actually had to pay attention in class.
Is this an Orthodox school?
No, not at all.
Was it windy today, or was it not bad?
It's so
It's windy? So you were running wind sprints with wind too?
We
right?
were in like a closed facility.
Oh, you were up in the bubble, whatever
Yeah.
that is? That looks pretty horrible.
It's colder in there than it is outside.
That's what it looks like. It looks like there's no heat, there's,
Yeah,
it's
and then they have like huge fans just blowing in. It's cold.
Yeah, I think I'd rather run outside.
Yeah.
It's and it's turf, right?
Yeah,
So it's,
it's like a 50-yard football field. And it was built for the football team, but the football team doesn't go over there because none of their facilities are over there.
oh, you got to be kidding.
So it makes no sense on why they.
That
do it.
makes no sense whatsoever.
I mean, I'm not complaining, but.
Now, soccer field, is it wider than a football field?
Yeah, it's wider.
It's wider.
but it's the same length with the end zones.
With the end zones, okay, okay. That's. Yeah, I don't know, it's like, so if you sit, you can't go back in, right? Is that the way you-
It depends on, like, NCAA has different rules than pro
Oh.
or other leagues,
Okay,
cause NCAA always switches things up.
that's, especially this year.
Especially this year.
So,
But typically, you're only allowed 3 subs.
Only allowed
Oh,
3 subs,
in Division One?
Not in Division
Oh,
One,
and that's,
like the real.
I got you.
and after your third, you're playing down?
What do you mean?
Like if you blow through, if you have 3 people get kicked out, do you have to play a man down or?
Yeah, if you get a red card, you have to play man down, but you have 3 subs, so you can switch out 3 players,
Okay,
and that's it.
okay. There's gotta be a strategy in that.
Yes, there is. Usually you don't sub until the second half.
Get the fresh legs in.
Yeah.
You guys have probably never seen the movie Slapshot?
I have. The hockey
Paul
movie?
Newman, yeah, that's where they had the Hanson brothers.
I think
They would
I've
just
seen
go in
it.
and be thugs and just the whole, it's a bad movie, it's Paul Newman, but it's just to injure people, that was all their job was, and, when I was playing, the coach would tell me, as a lineman, I know it's shocking to think of me as a lineman, but he would tell me to spit on the offensive guard's hand. That's what he told me to do, go in and spit. I never did it. He goes, you just spit on their hand, and then they'll raise up their hand, and then they'll get illegal motion. I'm like, okay, then you're gonna get the crap beat out of me. I'm not gonna go spit on the guy's hand. Yeah, the 70s was not a good time. I just remember like my coach having my face mask and just swearing so much at me, just swearing. Spit's going all over my face, he's just swearing. But by November, I was just so used to it, I was thinking about dinner as he was swearing at me, you know, it was just like, I mean, maybe coaches are better now, maybe they have kinder mouths than they.
Was that in high school?
That was in high school, yeah.
Or the high school?
Yeah,
coaches?
right, there was no college in this, so, yeah. Okay, let's stand up, stand up. Okay, we will have one more quest, before final quest, okay? We'll have one more quest the week after break, the week after Thanksgiving. Does that make sense? So that we'll have a quest probably that Friday, but you will not be here, you'll be at home or wherever you're at, so I'll have to figure out what we're doing. And then we'll have one more quest after that, which will be during final exam, I'm not sure I'm gonna have it during the final exam slot, because that's like December 18th, which seems absurdly late to be taking a quest. So I may set up some other times that you guys can take it to.
Like the week before, or? like-
No, probably not the week before, probably final exam week. Okay, let's sit back down. Well, you probably weren't focused too much as I was teaching on Friday, because you were thinking about the quest and not thinking about what we were doing. But we introduced a new function whose name was, well, not new to you, but new to us this semester, which was natural log, logarithm, okay? And logarithm's job is to undo who? It's the inverse function of e to the x, okay? It's the control z, okay? So like, for example, if E sends Apple to, I wasn't being real creative. If E sends Apple to capital A, then natural log would come along and take A and send him back to Apple. Or if E sent banana to capital B, then natural log would send capital B back to banana. And from these very simple relationships, we can come up with the two fundamental equations for inverse functions, specifically for these two inverse functions. If e to the, read this, e to the
Apple.
is
A.
a, but apple's equal to the, if I drove that up into there, imagine that this is a Toyota pickup, and I'm driving it up over top of the the Apple parking space, then that would mean e to the natural log of a. If apple's equal to the natural log of a, then e to the natural log of a would be equal to
A.
a. And what did you do, Dr. Warren? All I did was substitute. E to the apple is a, apple's the natural log of a, and just substitute, then e to the natural log of a is a. Now let's come over here and do just the opposite. E to the banana is b, but the natural log sends capital B back to banana. Then again, if I substitute e to the banana for capital B, then I would end up with this other equation which would say the natural log of e to the banana is banana. Very good, Miles. Is banana. Now, how many people realize math books aren't going to use fruit? How many people realize math books aren't going to use fruit? Math books like the variable x. In all cases, they like the variable x. So where you see the a, replace it with x. And where you see the banana, replace it with x. And those are our two fundamental relationships for the inverse functions, e and natural log. So the first one is that e to the natural log of x is x, and the other one is that the natural log of e to the x is also, x. So write those down. Those are two fundamental results. E to the natural log of x is x, and the natural log of e to the x is x. Are you guys following? Are you following at the grid? Are you following, guys? Okay. All right. Now write down e to the x. Write down e to the x and take its derivative. The derivative of e to the x is equal to what? Okay, good. Now write down e to the f of x. E to the f of x. And take its derivative. And the derivative of e to the f of x, e to any function f of x is what? E to the f of x times f prime of x. And it's using this that we can actually find the derivative of natural log. It's using this and this identity right here that we can actually find the derivative of natural log. Now, this is what I'm going for. I'm looking for this. I want to find the derivative of the natural log of x. Where's my erasers? Guys, I still have people taking quests. This is just such an unusual semester. I'm really struggling getting stuff back to you guys. I think for the first time in my life, and maybe the only semester in my life, I may put grades on Canvas. For the first time in my life.
I think that's a great idea.
Yeah. I don't know.
No complaints
Very
here.
good idea.
But it may be harder to get quests back to you physically, just because there's just so many people that are sick but it's normally so much simpler than this.
Dr. Warren, on Wednesday, you said you graded like the one you take.
Yeah, I've got quest 3 graded.
Do you think you can bring it? We could just-
I'll bring it because I've got the last one
Can
in,
we
so.
just like look at it, even if we don't take it, just like to see our grade?
That's not a bad idea. I've thought about putting them in envelopes outside of my office and letting you guys come by and grab them there. I don't have a strategy yet. I'm just not used to this. I'm kind of off balance.
Yeah, I got you.
Okay, how many people have followed so far? How many people have followed this so far? Okay, now look up here, e to the natural log of x is, and nobody's following, e to the natural log of x is,
X.
e to the natural log of x is,
X.
so no matter what x is, e to the natural log of x is
X.
x. Now Dad, remember Doug, remember I tell you about the time Doug came at me with the soda bottle? Remember I
Yes.
tell you about that?
Punish
Okay,
both of them.
what did Dad do?
Punish both of you.
Yeah, so imagine that I spanked this side with the derivative of x. Is that okay, provided I spank the other side with the derivative of x?
Yes.
So I'm gonna spank this side with the derivative, which is perfectly okay, provided I
Hit the other side.
hit the other side. So I probably should have done that, and I probably should have, let me restart. I mean, I know you guys, but for your notes, I'm gonna go like this. And then under here, this means implies, that means implies. I spank this side with the derivative, which is perfectly okay, provided I
Hit the other side.
hit the other side. Now, how many people are pretty comfortable with the derivative of the right-hand side? I mean, if you're looking at that, how many people are like, Dr. Warren, I probably have that one for you. What's the derivative of the right-hand side?
1.
1. What flashcard would be useful and helpful in taking the derivative of e to the natural log of x?
E to the X.
You're like e to the f of x. Who's in the f of x location? Who's in the f of x location? Natural log. And you're like, well, Dr. Warren, how do we do this? Well, let's just use the flashcard. Let's start off. It would be e to the natural log of x. Now notice, then I've got times f prime, and I'm looking at that. I don't have anything better right now than to write f prime. But look, guys, I want to find over here on this part of the, I want to find the derivative of the natural log of x. Is it now in play? Is it now on my soccer field? Is this guy now on the field?
Yes.
Okay, if I wanted to get this guy all by himself, what would I do with that guy? If I wanted to get this guy all by himself, what would I do with that guy?
Divide it.
If I slide that guy over there, okay, how many people are following so far? How many people are still with me? How about in the grid? Are you guys with me or not?
Yep.
Thank you. Thanks, Lindsay. Okay, now, what is e to the natural log of x equal to?
X.
So what would that denominator be equal to? X. And so we find that the derivative of the natural log of x is just the function 1 over x. The derivative of the natural log of x is just the function 1 over x. Does that seem like that's worth writing down? Does that seem like
Yes.
that's worth writing down? So that's a new flashcard. That's our new flashcard. We wanted to find the derivative of the natural log of x. And now we know. What's the derivative of natural log of x?
1 over X.
I hit it, and what's the derivative of natural log of x?
1 over X.
Okay, so now write this down. X to the 7th times the natural log of x. X to the 7th times the natural log of x. G of x equals x to the 7th times the natural log of x. Take the derivative of that function. What rule do you need to start with? Take the derivative of that function. What rule do you need to start with? Product rule. So go ahead and try to take that derivative. Okay, cheat around the room, look around the room, don't breathe on anybody. Okay, you guys hold up what you have for me, I'll cheat with you guys. Hold up what you've got, let me see what you got
And then I
there.
just
Let
simplified
me
it.
see there, Steve.
Yes.
Good, good.
You
Yeah,
did.
yeah, we're
I was just like,
learning,
woo.
we're learning.
I did it on like the first day in this room.
What?
I
Like-
went like this and it went like.
Oh, let's not injure ourselves after not playing soccer. No injuries. How did you get injured? Okay, what rule do you need? What rule do you need?
Brother.
So what's the derivative of the first?
7,
How many people got that? How many people got that? Am I done? And the
No.
answer is hell no. And then it's
You haven't even got my calculator.
natural log of x. Am I done?
No.
There's a big plus. And now, what do I write down next? X to the 7. Now, what's the derivative of the second?
Whenever I was.
1 over x. Now, if I wasn't going to use this and I just said don't simplify, which I might do, are you done at that point in time? Is the calculus over?
Yes.
But x to the 7th times 1 over x is x to the 6. So if I'm looking at this, this would be like 7x to the 6th, natural log of x, plus x to the 6th. I didn't say simplify. Now, what could you factor out of both of those? What could you factor out of both of those?
X to the 6.
X to the 6th. This is just algebra. And there's its factored form. No, it would be a little hard, but suppose I asked for critical points. Dr. Warren, you didn't. Suppose I asked for critical points. Well, one critical point, if I'm thinking about where this would be 0, one critical point would be 0. Does that make sense that would be a
Yeah.
critical point? The other critical point's a lot harder to find. It would be when 7 times the natural log of x plus 1 is equal to 0. And you're like, you want to find x, Dr. Warren, you want to find x. Well, let's take the 1 to the other side. When I do that, it would become when you take this 1 to the other side, it'd become a negative 1. So that would imply 7 times the natural log of x is equal to negative 1. How many people are following? Are you guys with me? Can you guys see at home? Then the natural log of x would be equal to negative 1/7. So I want to find the value of x that natural log would send to negative 1/7. And you're like, wow, if natural log, oh, I erased it. If E sends apple to A, then natural log of A is equal to apple. So if E sends apple to, then the natural log of A is apple. Let's go in reverse. If the natural log of A is apple, then A is equal to e to the apple. So let's look at what we have here. If the natural log of x is negative 1/7, who's in the A location? Who's in the A location?
X.
And who's in the apple location?
Negative 1/7.
Negative 1/7, then x would be equal to,
Negative 1/7.
not negative 1/7, but
Negative 1/7.
e to the negative 1/7. Or what you can think of is that you could e both sides. You could e both sides, which would get the x by itself. So what's your other critical point? And I'm pointing to it. I'm actually pointing to it. E to the negative 1/7. So I have two critical points. And we'll just stop with that. I know I wasn't even gonna go there. But how many people are understanding? Miles?
No,
Oh, you're understanding. Okay, good. Stand up. Stretch. Okay, sit back down. So somebody else is interested in doing setting up their classroom like this. So before I make any suggestions to them, like, is this working, the Zoom? I mean, like, having this set up, is this better? Is it worth the effort? Not, I mean, you guys can't see well. Is it better to be in class during Zoom, or is it better just to have a video? What do you guys think? Is Zoom better than just having a video where you can see it better? Okay, I mean, I don't wanna, I mean, it's more work for me, but I don't want another teacher to have to do it if that's not gonna help them.
I would say it's more helpful.
Is you, I mean, like, seriously, is it more helpful, would you?
Yeah.
Yeah.
I definitely think it's more helpful, but I appreciate that you also post the videos afterwards.
Well, I just, they're so blurry, I just am like, I know the iPad takes better videos, so. And if you look, guys, I mean, there's 7 of us here in the room, and then I'm looking at 4 rows of 16, that's 13, there's 20, there's 35 students. So how are the other 15 getting content? Probably by
Video.
drinking beer? No, probably by video is what I'm thinking they're using. Okay, all right, I'll tell them that. Okay, you guys don't remember this at all. But the graph of the inverse function is reflected along the line y equals x of the function. What did I just say?
It's reflected.
Dr. One, I heard nothing. The graph of the inverse function, say that,
The graph of the inverse function
is reflected.
is reflected
Now think about a reflection. Where do you see a reflection? In the mirror, it reflects, okay? Is reflected across the line y equals x of the function.
Oh.
So if this is the graph of e to the x, and this is the line y equals x over 1 up 1, then this would be the graph of, the inverse function. And who undoes e?
LN.
Natural log. So if we look here, notice, natural log, because e never crosses the x-axis, e to the anything is always, I'll try that again.
Positive.
E to the anything is always,
Positive.
e to the anything is always,
Positive.
it's always above the x-axis. The derivative of the x, always positive, the function's always, derivative is positive, the function's always increasing. What's the second derivative of e to the x? E to the x, always positive. So it's also always concave up. And so we have this graph that has this horizontal asymptote. It's always increasing, it's always smiling. It goes through the point 0, 1. So the inverse function goes through the point not 0, 1, but 1, 0. You know, like, Dr. One, how do you figure that out? Are you kidding? E to the 0 is?
1.
E sends 0 to?
1.
So natural log would send 1 back to?
0.
0. So natural log of 1 is 0. But notice it goes down this vertical asymptote as you approach 0. It gets nasty at 0, and then it grows really, really slow. It grows the exponential function grows really, really fast. The logarithm function grows really, really slow. Write that down. Logarithms grow really, really slow. That's why they use them for the Richter scale. The difference between a 5.0 quake and a 7.0 quake, is that pretty significant?
Yeah.
Yeah, we don't live in California, so we don't really care. Were you guys alive when we had the earthquake in Virginia? Were you guys alive when we had the earthquake in Virginia?
Was it like really tiny?
Yeah, you guys must have been young, but that kind of freaked me out. I've never been in an earthquake before. And, and it was just like, it wasn't like the ground was shaking, but it was like if something felt totally odd. It was like,
I was in my basement. We thought my brothers were jumping on the couch upstairs. We were like, guys, stop jumping.
no, it was
Not doing
really,
anything.
yeah, it's really strange if you've ever been in an earthquake. The logarithm function grows, if you put in natural log of like 1,000,000, It's a very, very small number. It's a very small. Natural log of 1 trillion, a really small number. I was watching the Olympics back before you were born. I guess it was maybe 1996. And there was this gymnast by the name of Paul Hamm, who would give the announcers. You know, gymnastics only becomes popular once every 4 years. Nobody cares at all about these gymnasts or these ice skaters. But once every 4 years, these guys become national heroes. And so this is what was happening. You know, this guy invested his life, Paul Hamm, and the guy who was, Tim Daggett was the guy who was the announcer, who was also a gymnast at one point in time. And he was saying this person had gotten so good over the last 4 years. He said, this is what he said. I remember I was teaching at the time, and I was watching the Olympics, watching this gymnastics thing. And he goes, Paul Hamm's increased logarithmically over the years. And I'm like, holy hell, you moron. Then nobody's going to watch you but once every 4 years, and now you're going to screw up kids for the rest of their life. They're going to think logarithmically means fast. It's increased logarithmically. And I'm just like, you've got to be kidding me. You've got to be kidding me. Logarithms grow slow. And then the next thing, they had Paul Hamm on. And this was the thing that blew me. Paul Hamm looked like, I've never been so jealous, I think, of a person's body before. It was like Michelangelo had cut this guy's body out of marble. He was there, and he'd be up and he'd be doing these iron crosses. And his legs, his arms were perfectly formed. Veins popping out beautifully everywhere. Definitely envious of this guy's body. But then he got down and he was talking, and he just won the gold medal, and he was like, well, that was really hard. And I was like, whoa, what's wrong with my television? You know? How does David talk like that? And I kept smacking my TV, and I'm like, what's wrong with this thing? He's like, that was hard, I've really working so hard, I know. And I'm like, how can that body be talking like that? And then I remembered the pommel horse. He probably wasn't always as great on the pommel horse. There had to be lots of accidents in gymnastic. Like if you, sorry, enough, okay, I'm not, yeah, no, okay, I know, I'm old, I'm not politically correct, but, okay, gymnastics. Logarithm means you grow, exponential means you grow.
Who
Okay.
says that in general? Like you hear the word like exponential, but you never hear like
Logarithm, but no, he brought that up trying to sound smart. Logarithmic, they're growing logarithmically, and I'm just like, okay, you just screwed up a whole generation. Nobody would even care what you said, except in this 4 years. Okay. Stand up again, stand up again.
Got it.
Okay, right, sit down. Sit down. Dr. Warren, no stretching? No stretching. Okay, if e to the sun equals ice cream cone, write that down. If e to the sun equals ice cream cone, what must logically follow? So what do you guys have? What do you guys have for me? What do you have for me? Then what? Then what? Then what? The natural log of
Ice cream cone.
ice cream cone is equal to sun. Okay, now we're going here. Now we're going here. Okay, so if sun is equal to the natural log of ice cream cone, put that up there for sun and write down another identity. Put that up there for sun and write down another identity. Okay, cheat, look around, ask people in the room. You guys cheat with me. Hold up what you've got. Hold up what you got. Let me see, Alex, what do you got there? Oh, good.
That was really distracting.
Good.
Maybe the line of ice cream cone equals sun.
then e to the
Ln
natural log of
ice cream cone.
ice cream cone equals
Ice cream cone.
Ice cream.
equals ice cream cone. How many people got that? How many people got that?
Ice cream cone.
Okay, now, help me out. You're not gonna like it, but where you see the ice cream cone in this identity, put f of x. Where you
And the whole identity,
see,
Dr. Warren?
where you see the ice cream cone in this identity, put f of x. I guess put g of x, that way I think it'll be easier for you. Put g of x, not f of x. So then we would have e to the, you guys help me out, we would have e to the natural log of g of x is equal to g of x. In the grid, are you with me? Are you with me with this? Are you with me? Okay, so now what I want you to do is on the line right underneath this, don't take the derivative, but take the derivative. Spank both sides with the derivative. Spank both sides of that identity with the derivative. So I spank this side with the derivative, and what would I get on the other side if I take the derivative? G prime of x. Okay, focus, focus, focus. Let's take the derivative of this side. E to the f of x. Dr. Warren, it's not f of x, it's natural log of g of x. It's an f of x. The derivative of e to the f of x is equal to, what do you got in your brain? The derivative of e to the f of x is equal to e to the f of x times
F prime.
f prime of x. So this would imply this derivative is equal to e to the f of x, but who's f of x? Who's playing the role of f of x? Get out of your way here. Times the derivative of the natural log of f of x, which is natural log of g of x, is equal to the right-hand side, which hasn't done anything, which is g prime of x. Are you still with me? Are you still with me, guys?
Yes.
Okay. This is e to the natural log of g of x. But e to the natural log of g of x is the same thing as g of x. So this would imply this is the same thing as, that is the same thing as, so I would have g of x times natural log of g of x prime is equal to g prime of x. Now get this derivative all by itself. What would you do? What would you need to do to get this derivative all by itself? Divide by who? Divide by who? G of x. So do that. And you've just come up with another flashcard. We've just shown that the derivative of natural log of g of x is a fraction. The numerator is g prime of x, and the denominator is g of x. So you guys have just come up with a chain rule for natural log. If natural log is pregnant with g of x, its derivative is g prime of x divided by g of x. But guys, how important is this, all this crap over here? How important, I mean, how important was understanding this in our derivations today?
Understanding it.
Okay, so now here we go. We're gonna play flash derivatives. We're gonna play flash derivatives. Derivative of x is 7. Derivative of x is fast as you can, fast as you can. Derivative of x is 7. Derivative of x is 7. Derivative of f of x to the 7th. Derivative of f of x to the 7th. Derivative of f of x to the 7th. 7f of x to the 6 times f prime of x. Derivative of the x, derivative of the x, derivative of the x. Derivative of the f of x, derivative of the f of x.
Unity f of x times f prime of x.
New one, derivative of natural log of x.
X over 1,
One over x.
or 1 over x.
Without looking at the board, the derivative of natural log of g of x.
G prime of x is minus g of x.
So like for example, suppose you have this function, h of x is equal to the natural log of x squared plus 7x plus 6. How many people think they could take the derivative of that? How many people think they could take the derivative of that? If this is h of x, how many people think they could find the derivative of h prime of x? Who's the g of x? Who's the g of x?
X squared plus 7x plus 6.
X squared plus 7x plus 6. So find the derivative of that. Find the derivative of that. What is the derivative of natural log of x squared plus 7x plus 6? And what do you guys have? What do you have? What do you have? It would be
2x plus 7.
2x plus 7. Are you done? Are you
Divided
done?
by.
Divided by
X squared plus 7x plus 6.
x squared plus 7x plus 6. Is this making sense? Is this making
Yes.
sense? Okay, so now you know I just can't leave you alone. Suppose you have this, w of x is equal to x to the 14th times the natural log. Ho, 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 ho. And natural log is pregnant with e to the x
What the hell?
plus x to the 3rd. Take the derivative of that nightmare. Take the derivative of that nightmare. I'll read it again for everybody at home. It's x to the 14th natural log, and inside the natural log is e to the x plus x cubed. Take the derivative of that nightmare. Okay, let's see how we're doing. Okay, this is a multi-step karate move. This is a multi-step karate move. And I've lost all my people. This is a multi-step karate move. What rule do you need to start with? Product rule. How many saw that it was a product rule? How many people saw it? Okay, how many people are comfortable they can take the derivative of the first? How many people are pretty comfortable they can take the derivative of the first? Not as comfortable with the derivative of the second, but I'm willing to bet you're not gonna do too bad. What's the derivative of the first? 14x to the 13. Am I done? And the answer is no. Times
Natural log of x
plus.
x squared through cube.
Now am I done?
Plus.
Plus.
X to 14.
Okay, now it gets harder. Natural log's pregnant, but that's not hard if you just remember. What's the flashcard for a pregnant natural log? G prime of x over g of x. How many people are pretty comfortable they can take the derivative of the numerator, of this thing? What would g prime be?
E to the x plus 3x squared.
Am I done?
No.
Divided by,
E to the x plus x cubed.
and there's your derivative. It's not nice, but there's your derivative. Is this making sense? Is this making sense? Okay, okay. Stand up again, stand up again. Stretch, stretch. Okay, let me just talk about some properties of the natural log function, then I'm gonna let you go. Let me talk about some properties of the natural log function, then I'm gonna let you go. And I wanna show you that they come from the exponential function. Do you guys remember property for that? E to the apple times e to the banana is equal to what? E to the
Apple plus banana.
e to the apple plus banana. How many people remember that from high school? How many people remember that from high school? Now let's suppose, Dr. Warren, I hate this. Let's suppose that e to the apple is equal to a, and e to the banana is equal to b. Then this would be the same thing as, if this is e to the apple and this is e to the banana, then this would be the same thing as a times b. So then we would have a times b is equal to, a times b is equal to
Equal to
e to the
apple plus banana.
e to the apple plus banana. How many people are following? I know it seems like a shell game. Jonathan, are you with me? Jonathan, are you with me? Okay. Aiden, are you with me? Okay. Now this is where it gets harder. If E sends apple plus banana to, A times B, then natural log would send A times B back to, if E sends apple plus banana to AB, then natural log would send AB back to apple plus banana. Dr. One, what are you doing? Just wait. If E sends apple to, then natural log would send A back to apple. And then what would happen there? You guys do the similar thing for that one. If E sends banana to B, then what would follow from that? And what do you guys have? The natural log of B would be equal to, banana. My bananas are looking worse. Okay, so let's go back here. Then the natural log of AB is equal to apple plus banana, but apple over there is equal to the, and banana is equal to the, so we get that this is equal to the natural log of A plus the natural log of B. And this is a property of logarithms. The natural log of a times b, the natural log of a times b, the natural log of a times b is equal to the natural log of a plus the natural log of b. Now notice, this isn't calculus, guys. This isn't this is pre-calculus. This is stuff just about these guys being inverses. There's another one, I'm not deriving it. There's another one that's the natural log of a over b. It follows the same way. It follows the same way. The natural log of a over b is equal to the natural log of a, the natural log of the numerator, minus the natural log of the denominator. That's another one. That's another one. And again, this is not calculus. This isn't derivative formulas. These are just properties of the log. The last one is the most fun. If you have the natural log of a raised to an exponent, this is the one that's the most fun. If you have the natural log of a raised to an exponent, it's the same thing as p times the natural log of a. It's like you can take that exponent and drop it down. You can take the exponent and drop it down. And this is sometimes really useful. Let me show you one application. And then I'm going to free you. Suppose I gave you this. And said, take the derivative of that beast. Take the derivative of that beast. Don't. Don't. You could. Is natural log pregnant? Is natural log pregnant?
Yes.
So I know it would be g prime divided by the natural log of g. So it'd be 1 over this crap divided by this crap, which would be a power rule flashcard. But what can I do with the 201?
Pull it in front.
Pull it in front. So without doing a lick of calculus, without doing any calculus, I can start by just saying, oh, well, this is the same thing as 201 times the natural log of x squared plus 7x plus 5. Now, does this help? Does this help, guys? Does this help?
Yes.
This is just a constant. So then h prime of x, the constant multiplier, just hangs in front. Now, let's do this with the pregnant. I would have what on the bottom? I would have what on the bottom?
X squared plus 7.
And then what goes on the top? What goes on the top, guys?
2x plus 7.
2x plus 7. And then you're done. And then you're done. And then you're done. So these pre-calc flashcards are useful at times. Oh gosh. Okay. I'm letting you off 5 minutes early. I'm letting you out 5 minutes early today. On Wednesday, calculus is about limits, derivatives, and
Integrals.
guess what we're starting on
No.
Wednesday? Guess what? Integral.
Dr. Ward, you
Integration. We finally reached integrals.
Dr. Warren, do we have a website to go
Yes.
Start studying.
Because
And do we have, are you having class on Friday?
I just
I'm
forgot.
having class on
I
Friday.
don't even remember. I remember that I sucked.
I don't know how many will come to my class.
Let's see.
Oh, that thing, that's.
Antiderivatives.
sucks. Yeah, that took me so long to learn that, and then by the time we learned it, we already had like a test and we were moving on.
Yeah, I know.
To like U
Yep.
substitution, I was like, what the hell?
Uh-huh.
I doubt we'll get to use substitutions.
Really?
Will we?
Thank you. I don't understand, like, I never learned why I ever needed to know that.
There's apparently, there's like a complicated
Oh,
machine that you can't easily take like
I'm so glad you didn't hurt yourself.
And then you just like plug it in or something.
You just give it Q, I think.
Thank you.
I had one question of U substitution on my AP exam, one, and it was the easiest U substitution, and yet I like got an F on my test because of U substitution, so I don't understand what the whole point of that was. You know what, it's fine.
Thank you, Dr.
Warren, I'll see you later for office hours.
All right, thanks, Lindsay. Alex, you didn't get hurt, right?
No, I'm good. Thank you so much for letting me come in.
Was it fun?
It was so fun. That's been my best day at JMU so far.
All right, that's what I wanna hear.
I can send you a picture of the route I did if you
Thanks,
want.
Dr. Warren.
Did you go to West Virginia?
Yeah, it was Franklin.
Oh, that's,
Or
No, I can't.
Alright.
Bye,
pretty
Dr.
hard.
Warren. Bye, Alex.
Bye, Alex.
Oh wait, I was gonna say, Dr. Warren, if you, and Alex, are you gonna be here for class on Wednesday, or are you coming Wednesday night?
I'm thinking that well, if I came on Wednesday, part of the reason would be to go to math class, so I
Okay.
probably would go earlier. But
Okay.
I'm still trying to figure out how that would work, because I wanna get, to the last 2 in-person math classes if I can.
Yeah, because I was also gonna say, if you're not here, Dr. Warren, can I just take her test if you end up just giving it back?
Yeah.
She'll be
yeah,
here, like-
sure, as long as
Okay.
she says it's okay.
Yeah, Alex, just give your permission if you're not gonna be here. So I think you're
I
on.
have her permission.
All right.
I know where she lives, Dr. Warren, it's okay.
Wrap it up.
Bye.
Bye.
Bye, Dr. Warren.
See you, Alex.